Good afternoon, everyone, and thank you for joining us for today's online panel, Green Infrastructure in New Jersey Stormwater Management. I'm Tom Herrington, the Associate Director of the Monmouth Urban Coast Institute and the moderator for today's discussion. I'd like to acknowledge our co-organizers for this event, Clean Ocean Action, the Deal Lake Watershed Alliance, the Jersey Shore Group, New Jersey chapter of the Sierra Club, the Long Branch Green Team, and the Whale Pond Brook Watershed Association. A cornerstone to the DEP's recently amended stormwater standards is the requirement for permit applications to use green infrastructure, such as rain gardens, bioretention basins, and green roofs, rather than the more traditional gray engineering structures to reduce stormwater runoff and pollution. The NJDEP announced the measures in the spring and set March 2021 as a deadline for municipalities to reflect the changes in their local ordinance and to train their engineers and review staffs to handle the new rules. Our panel today includes one of the NJDEP officials who's helped craft these regulations and stormwater experts from throughout the state who will share their knowledge on the topic. So before we get started, I'd like to walk through a few details on how the webinar will proceed. Following the presentations, we'll open up a Q&A session for everyone in attendance. Until then, you're also welcome to put your questions in the chat. We'll monitor the chat and we'll read your questions out loud at the end of the presentations, or if the speakers want to, they could answer the chat questions themselves. For those that can't join us today, the webinar is being recorded and the slides will be posted within a few days on the Urban Coast Institute's website at monmouth.edu/UCI. And with that, I think we'll introduce our first speaker. Our first speaker is Gabe Mahon, Bureau Chief of the NJDEP Division of Water Quality. Gabe holds a Bachelor of Science in Chemical Engineering from Lafayette College, and he is currently a licensed professional engineer in both Pennsylvania and Delaware. He spent the first 12 years of his professional career working with the NJDEP Division of Land Use Regulation as an environmental engineer responsible for reviewing the engineering aspects of land use regulation applications and to ensure compliance with the Flood Hazard Control Act rules, the Coastal Zone Management rules, the Stormwater Management rules, and the Freshwater Wetlands Protection Act rules. For the last 4 years, he's been working in the Division of Water Quality, where he's now the Bureau Chief, and he's responsible for managing the Industrial Stormwater Permitting Program, Discharge to Groundwater Program, On-Site Wastewater Management Program, and the Municipal Stormwater Regulation Program, which includes the Stormwater Management rules. That sounds like a lot to have on one's plate. So Gabe, if you're ready, we'll send it over to your presentation.
All right, thank you. Let me just take 1 minute to share my screen here. There we go. I think you can all see that now, right? All right, excellent. So thanks for the introduction. As he said, my name is Gabriel Mahon. I'm the Bureau Chief of the Bureau of Non-Point Pollution Control in the Division of Water Quality. And today we're going to talk a bit about the stormwater management rules applicability and the amendments that we recently adopted. First thing I want to go over is just a little specifics about exactly what we're talking about. So how is post-construction stormwater managed in New Jersey? And I say post-construction, I want to just emphasize that we're talking about post-construction. It's how is the stormwater management managed after construction is completed. There's a whole different set of regulations that govern how stormwater is managed during construction, and that's not what we're going to be talking about. So post-construction management is really handled by the stormwater management rules, which are NJAC 7:8. And there's two ways that an applicant's going to wind up getting reviewed under these rules. One is they come to the department because they need a permit from land use regulation. Now there is a bit of a reorganization happening at the department, so I think land use regulations name might be changing slightly, but it's really still the same program. They do the flood hazard permits, the wetland permits, the highlands permits, CAFRA permits. And if you're also a major development, which is the trigger for being subject to the stormwater management rules, and you need one of those permits, then the department reviews to make sure you meet the stormwater management rules. On the other hand, if you don't need a permit from the department, and the reality is the vast majority of developments in the state don't need a permit from the department, then in that case, you're getting reviewed at the local level. because our municipal separate storm sewer system program, our MS4 program, requires municipalities to implement the stormwater management rules for the developments that happen in their municipality. And there's really two ways that can happen, and I know this can be sometimes confusing. It's even confusing for me at times, but if the project's residential, then it's going to get reviewed against the residential site improvement standards, the RSIS. And the RSIS then specifically says meet the stormwater management rules. So in that case, more or less, they're being reviewed against the stormwater management rules. On the other hand, if it's non-residential, of course, then the RSIS won't apply. So in that case, the municipality has to have an ordinance that they adopt themselves that's at least as stringent as the stormwater management rules. And this is where things can get more complicated because, like I said, it's at least as stringent as the stormwater management rules, but the municipality can actually make it more stringent, even much more stringent if they want it to be. So whereas for residential, it's uniform across the state, and that's one of the goals of the RSIS is to make the requirements for residential projects uniform across the state. When it comes to non-residential projects, you really have to look at the local stormwater control ordinance. Of course, we do have a model ordinance that we put out, and many municipalities just adopt our model ordinance, but many other municipalities have chosen to modify the model somewhat or to even create their own ordinance that's as stringent as our rules. So keep that in mind. You've always got to look at the ordinance if it's a non-residential project. Now let's talk about the amendments. This is the schedule of the amendments. We originally proposed them back on December 3rd of 2018. We had a public hearing about that on January 8th of 2019. The public comment period closed on February 1st of 2019. And then we filed for adoption on December 3rd of 2019. If you're familiar with how the rule process works, you have 1 year from when you propose to adopt, to file for adoption. And you can see we did it exactly on the last day we had. So we filed for adoption, I think about an hour or 2 hours before the deadline there for us. Now the rules didn't actually get published in the register until March 2nd of 2021. And they come with a 1 year delayed operative date from that publication. So the rules won't actually become operative until March 2nd of 2021, which is next year. Until that time, our current rules, the same rules that we did before the proposal, are still in effect. And there's a few reasons why we're doing that. You know, obviously it's a complicated procedure to design your stormwater management for a site. So we don't just change them on a whim. We give people an opportunity to finalize the things that were already mostly completed before they start having to design for the new standards. So that's part of what the delayed operative date allows, but also at the same time, we do need to give time for those municipalities to update their ordinances. So our MS4 permit already sets forth a provision in the permit that basically says if we notify a municipality that their ordinance isn't up to standard, they have 1 year to fix it. And so we just use that same time frame, 1 year. And the day that we published the adoption on March 2nd of 2020, we sent notices to every municipality in the state, letting them know that their ordinance was no longer sufficient and they had 1 year to revise it. Okay, importantly, what projects have to comply with these rules? Like I mentioned briefly before, the term is called major development. And what we're looking at here is the definition under the newly adopted rules. So what will become effective on March 2nd of 2021. But it's not tremendously different from our existing definition. I've highlighted some of the major differences and I'll go over why we did that. First, if you read the intro language, it says it means an individual development as well as multiple developments that individually or collectively result in any of the things below. So keep that in mind. You can't break projects up into smaller projects at the same site to avoid regulation. It's going to count all the projects together. Or you can't break phased projects up or anything like that. It counts them all together. And we've always done that, but we did change that language slightly to just make it more clear because we originally used the term ultimately disturbing more than 1 acre. And sometimes that could have been confusing. So this clarifies that. The next thing is the disturbance of 1 or more acres of land in the definition. Now that's the same as it is under today's rules, except we've added the February 2nd, 2004 timeframe to it. And that is really a clarification on our part with the use of the term ultimately disturbing 1 or more acres of land. That question sometimes came up. Well, what if I did disturbance in 1990? Does that count towards the 1 acre? So we've made that clear that it's tied to February 2nd, 2004. And that's when the rules really were adopted in the relatively current form. The next thing is the creation of the creation of 1/4 acre or more of regulated impervious surface since February 2nd, 2004. Again, the creation of 1/4 acre or more of impervious surface is currently in the rule. We've also tied that to February 2nd, 2004, because that's when that 1/4 acre was added to the rule. And the only other difference we have here is the term regulated impervious surface. So this is something that we added to the rule. I will briefly touch on it later in another slide to explain what regulated is, but keep that in mind. It's a defined term. And the next thing here is number 3, which is completely added to the rule. So this is the creation of 1/4 acre or more of regulated motor vehicle surface. Since this is completely added to the rule at this point, it's tied to March 2nd, 2021, the operative date of these amendments. It's not backward looking. And the reason we've added this is because we've made some slight changes to the applicability of the water quality provisions, which I'll talk about in a bit, but it required us to make this change here to line those up. And the fourth thing here is a combination of 2 and 3 that equals 1/4 acre or more. Fairly obvious, I think. One caveat here is you would never count the same area twice, right? So if you're constructing an 1/8 of an acre parking lot, well, that technically is regulated impervious surface, and that's technically regulated motor vehicle surface, but you wouldn't count it as an 1/8 of each to say that's 1/4 acre total and it's major development. No, as long as that's not associated with any other work, then that's just an 1/8 of an acre of land, so it can't add up to 1/4 acre. You don't count it twice. A couple other caveats here. This is the definition in the stormwater management rules at NJAC 7:8-1.2. So that's the definition section of the rule. However, if, as I said before, you're being reviewed at the municipal level, you might go through the RSIS. Well, the RSIS doesn't have the exact same definition of major development. The RSIS just defines major development as those projects that disturb more than 1 acre of land. There has been some discussions. DCA manages the RSIS, so there's been some discussions with DCA about changing that definition to line it up with ours. I believe that is the plan, although I haven't seen any sort of proposal come out of that yet. And the other thing is the stormwater control ordinance. And again, like I said before, you got to look to the stormwater control ordinance at the local level to know what it says. And the same is true regarding this definition of major development, because they can have a different definition of major development than what the stormwater management rules says. So the major thing there is that they actually only have to include the 1 acre of disturbance. That's the federal minimum standard under the MS4 program. And that's all we mandated the municipalities to do at this time. But many municipalities have chosen to either have smaller thresholds, say that 1/2 acre of disturbance, or I've seen it as low as 5,000 square feet of disturbance, or they've chosen to just adopt our exact definition, which would include the 1/4 acre. So you really do need to look at the local stormwater control ordinance to know exactly what their definition is. Just want to go over the major changes in the rules. This is the existing layout of subchapter 5, and subchapter 5 is the main part of the rules that contains all the requirements for what you do for your stormwater management on an individual site. So we've got the scope, we've got the stormwater management measures for major development, which are really things that apply to all projects. And we've got the non-structural stormwater management strategies. You've got erosion control, groundwater recharge, and runoff quantity all packed together at 5.4. Then quality is 5.5. 5.6 is how you do your calculations. 5.7 is standards for structural stormwater management measures. 5.8 is maintenance. 5.9 is your sources for technical guidance. These are the changes that we're making. So one of the major changes, of course, is to introduce green infrastructure as a requirement. And what we're doing is we're actually removing the non-structural stormwater management strategies as something that need to be evaluated on a site-by-site basis. We're moving those back into the municipal planning requirements and requiring the municipality to incorporate that into their planning as an overall whole of their whole municipality, rather than looking at it on an individual site basis. But that clears that section out, and that's where we put the green infrastructure requirements. Other things we did was we looked to 5.7, the standards for structural stormwater management measures. We said, well, these are really generic things that really apply to all projects. We could put that into 5.2 and clear that space in 5.7 for ourselves. So we did that. We moved all the requirements in 5.7 up into 5.2. And then we moved the calculations from 5.6 down to 5.7. And what that did for us was it cleared out 5.6, and we moved runoff quantity down there into 5.6. We also moved erosion control up into 5.2, the stormwater management measures for major development, because that's also a requirement that really applied to all projects. And we don't really have any erosion control standards per se in our rule. It just says meet the soil erosion and sediment control standards. So we didn't feel it was necessary to house it there with the other major requirements in our rules. So after we do all that, we have scope as 5.1, stormwater management measures for major development as 5.2, but keep in mind there's a lot more information there now than there was before. We've got 5.3 is green infrastructure, 5.4 groundwater recharge, 5.5 is stormwater runoff quality, 5.6 is quantity, 5.7 is the calculations, and 5.8 and 5.9 are still the same. They remain unchanged. So what this has done for us, though, I think, is made the rule a lot more streamlined and clear. The major requirements each have their own section in the rule rather than multiple things being combined together, which sometimes led to some confusion. So hopefully this clarity leads to better designs that are more compliant. Let's get into the actual green infrastructure standards. First thing we're going to want to talk about is the definition of green infrastructure under our rule. This is it right here, straight cut and paste from the rule. It's a stormwater management measure that manages stormwater close to its source by treating stormwater runoff through infiltration into the subsoil, treating it through filtration by vegetation or soil, or storing stormwater runoff for reuse. Before we get the question, I'll just answer it now. Why doesn't this say anything about evapotranspiration? Well, we're talking about generally designing stormwater management measures to manage the 100-year storm. The amount of evapotranspiration that happens during the maybe at most 72 hours that water is supposed to be in a stormwater management basin during a 100-year storm, the evapotranspiration is really not significant enough for us to be including it in the calculations. So it's really not part of our calculations anywhere, which is why it's not specifically mentioned here. But if you think of any of those basins you're thinking of that do evapotranspiration, they all fit into either number 1 or number 2. Either they're going to be providing infiltration. If it's a bioretention basin that infiltrates, then it'll fit number 1. And that would also fit number 2 most likely. And I think that's also most of the evapotranspiration type BMPs are going to fall into number 2 because there's going to be vegetation, there's going to be soil. So even though it's not specifically mentioned here, it's covered by our definition. This is the slide on the green infrastructure standard itself. The standard is relatively straightforward. You just have to use green infrastructure BMPs to meet our other requirements. You have to use green infrastructure to meet recharge, quantity, and quality. The only caveat is that you need to use small scale green infrastructure to meet recharge and quality. You can use large scale green infrastructure to meet the quantity standard, but keep in mind it still needs to be green infrastructure. We created 3 tables in the rules to outline all the different BMPs we have and what standards they can comply with. When we go through those, we'll talk about what makes each one small scale versus large scale. And then the other thing we've done is we've maintained, and this was already in the existing rules, an ability for someone to propose an alternative BMP. So these tables are going to list what's in our stormwater BMP manual. Of course, someone could always propose some BMP that we don't have, and there's a method for us to evaluate that. Just keep in mind that basically you could think of what's in the BMP manual as already department approved BMPs. So if you're going to use them, you don't have to justify that they're going to work. As long as you just follow our design, they're accepted. If you're proposing some sort of alternative BMP, then it becomes your obligation and your responsibility to prove to the review agency that it's going to work. So that puts much more of the burden on the designer at that point. This is table 5.1. These are the small scale green infrastructure BMPs. You can use them for recharge, quality, or quantity. We'll go right through the list. We got cisterns. They don't have a drainage area limitation to make them small scale. Dry wells have a drainage area limitation of 1 acre. Grass swales don't specifically have a drainage area limitation, but a grass swale, based on its design criteria, has a relatively limiting area already because you need to maintain that the flow is, I think, maximum 2 inches, and there's a certain maximum velocity you can have. So really, you can't have a grass swale capturing a huge area and still meet the requirements. Green roof doesn't have a drainage area limit because in general, you're not putting drainage onto a green roof. Manufactured treatment devices, they have a drainage area limit of 2.5 acres. Now you might be wondering why you're seeing manufactured treatment devices on a slide that says they're green infrastructure. There's a lot of kinds of manufactured treatment devices, and we actually do have a few that are basically small scale bioretention systems. And so those do meet the definition of green infrastructure, and that's the type we're talking about here. Next is pervious paving systems. They have a drainage area limit. This one's a little different. You can have 3 times your pervious paving system's area flow onto the pervious paving system. So it's a 3-to-1 ratio. So let's say you construct 1 acre of pervious paving. You could have 3 acres of regular impervious pavement flow onto that, and it meets the drainage area limit. Then we've got small scale bioretention systems, small scale infiltration basins, small scale sand filters. All 3 of those have a 2.5 acre drainage area limitation. And then we've got vegetative filter strips. Those don't specifically have a drainage area limitation, but again, like grass swales, their design criteria is set up in such a way that it's already very limiting. You have to have sheet flow flowing in there, and sheet flow can only extend for 100 feet. So the maximum length you can have flowing into this vegetative filter strip is already only 100 feet. So you really can't have a huge area draining there. Now this is table 5.2. Keep in mind, this is still green infrastructure, but these are no longer the small scale type. So you can only use these for quantity control. That's bioretention systems, infiltration basins, and sand filters. Of course, those are all the same from the last chart, except that in this case, they just don't meet that drainage area limit. So they have more than 2.5 acres draining to them. So they're no longer small scale. You can't use them for quality or recharge at that point, but you can still use them for quantity. And this also adds standard constructed wetlands and wet ponds. Those don't appear in the earlier chart because they have such significant requirements for hydrology that they need to have large drainage areas to maintain their permanent pools. Standard constructed wetland, there's several varieties we have, but the variety with the lowest drainage area limit is still 10 acres. And for a wet pond, our limit is 20 acres. So they really don't fit our model of small scale. One other thing to keep in mind here is that a wet pond, in order to be green infrastructure, has to have something to help meet that definition we showed earlier. So it's got to have vegetation, it's got to have reuse, something to make it green infrastructure. And these are the BMPs that aren't green infrastructure. So the only way you can get to them is some sort of waiver. That is still possible, so we retain them, but generally they're not going to be used as much. That's blue roofs, regular extended detention basin, manufactured treatment devices that aren't green infrastructure. We've got sand filters. You've now seen that sand filters are on all three charts. It's because we have several designs for sand filters. Either they infiltrate or they don't. So if it infiltrates, it's going to meet the definition of green infrastructure. And then if it's small scale and it infiltrates, it'll be on table 5.1. If it's large scale and infiltrates, it'll be on table 5.2. And if it doesn't infiltrate, it'll be on table 5.3 here, regardless of whether it's large or small scale. We've also got subsurface gravel wetlands here. And we've got the wet ponds that don't have that vegetation or reuse. So they wouldn't be green infrastructure. Okay, that pretty much summarizes the green infrastructure standard. I'm going to go into the next big change we made, which is a change to the water quality section. What we've done here is we've revised the applicability of the water quality section. Instead of being triggered whenever you create a 1/4 acre of impervious surface, we've changed it to creating a 1/4 acre of motor vehicle surface. And we've done that for a couple of reasons. One, that lines up with our implementation. We never made people treat water quality for rooftop areas or sidewalks, areas that weren't vehicularly traveled. So lining our rules up with our implementation is important, in my opinion, for transparency. But the other reason is we do want to make people treat other vehicular surfaces that aren't necessarily impervious. So we would see a lot of people propose, say, a gravel parking lot or a dirt roadway or a gravel roadway, and then say, well, it's not impervious, I don't have to do water quality. So we really wanted to put a stop to that, particularly since studies show that the amount of total suspended solids that come off dirt roadways and gravel roadways is actually much higher than paved roadways. So we definitely want to get treatment for those types of roadways. It's also important to note that this is going to be included in the definition of major development, right? We went over that before. That this was number 3 that was added to the definition because we've changed the applicability here to motor vehicle surface. We didn't want to run into a situation where someone creates a 1/4 acre of motor vehicle surface, and that would trigger our water quality with these changes. But if we didn't change major development, it wouldn't have been subject to the rules in the first place. So we needed to change both to make sure that someone creates a 1/4 acre of motor vehicle surface, that it's both major development and triggers the water quality standards. Next thing I want to cover is some definitions that we did to clarify the applicability of the rules. I briefly touched on the fact that we created this. So there's definitions of regulated motor vehicle surface and regulated impervious surface. And what these do is they incorporate some concepts from our frequently asked questions, but I think they're very logical if you think about it. So regulated motor vehicle surface is really going to focus on things that are water quality specific. So these are things like situations where you have an existing roadway and let's say the water flows off the roadway into the forest that surrounds there, it never makes it down to the stream, and someone proposes to put curbs and a collection system in this roadway. Well, now they're going to discharge that right into the stream. It's new impervious surface to the stream because those pollutants were never getting there before, or at least not to the same degree. So that's something we felt needed to be regulated, and we long did regulate that sort of thing through our frequently asked questions, but now this is very clear and added to the rule using that definition of regulated motor vehicle surface. Regulated impervious surface has similar concepts, except they're focused on flooding rather than water quality. So this would be things like expanding the capacity of an existing treatment system, right? You didn't create new surface, not treatment system, collection system. So you didn't create new impervious surface, but if the collection system was undersized and now you're going to make it 3 times larger or something, well, flow could get down to the stream faster because of that, and that could have adverse flooding impacts that need to be analyzed before it should be approved. A couple other things that we did to clarify applicability. One of them is that we added a requirement that all the standards need to be met in each drainage area on site, unless those drainage areas converge on site. We had this previously, but it was only contained in the water quality section. We've expanded it so it applies to water quality, quantity, and recharge. We've also moved our groundwater mounding analysis requirement from the recharge section into the section that applies to everything. Of course, most of those BMPs are doing recharge, but sometimes those infiltration BMPs are for water quality and not recharge. So we just wanted to make it clear it's for everything. It's not just if they're for recharge. Last thing I really want to touch on is the changes we made to the variance section of our rules. So I don't know if any of you are really familiar with what it says now, but there's not a lot of information. So it does allow a municipality to grant a variance if someone's going to do, if someone is willing to do mitigation in the same drainage area. But there was no restrictions on when you could grant it. A municipality could grant it if they felt like it, as long as they had a mitigation plan in their municipal stormwater management plan. So the requirement to have that mitigation plan still exists, but we've clarified now that you can only grant a variance if it's technically impracticable on site. And it has to be for engineering, environmental, or safety reasons. And the applicant still needs to come as close to meeting the requirements on site as they can. So they can't just say, well, let me get a variance, I'll do it off site. They have to come as close to meeting on site as they can. And we've also clarified that it only applies to the individual drainage area and performance standards. So they couldn't come in and say, well, I can't meet water quality here, but let me just do all my water quality as mitigation. No, they still need to do what they can on site. And then after that, they can just make up what they couldn't meet on site as mitigation. We've also clarified that it can either be a project that's in the municipal mitigation plan, or the municipal mitigation plan can set up criteria for the municipality to evaluate a project selected by the applicant or proposed by the applicant. It has to be approved no later than preliminary or final site plan approval, right? Obviously, you can't just defer your mitigation to some nebulous time in the future. It has to be located in the same HUC 14, previously just said drainage area, which kind of a vague term. So we clarified that by saying HUC 14. It also has to be constructed prior to or concurrent with the major development, right? Because if you could potentially have adverse impacts by not doing your stormwater management, well, if the same idea is true, if you don't construct your mitigation first, and you construct the major development first, well, there could be adverse impacts to the property owners surrounding that if you don't do your mitigation. It has to comply with the green infrastructure standards. We've also clarified that the applicant or the party responsible for maintenance of the major development has to be responsible for the mitigation as well. So you can't pass the mitigation of the major or the maintenance of the mitigation off to some third party. It has to be the same group that's involved with the application, either the applicant themselves, or if, let's say, it's a residential development where you're establishing a homeowners association that's going to do the maintenance of the BMPs on site, then they can be responsible for the maintenance of the mitigation as well. And maintenance responsibility can only be transferred to a public agency if there's a written agreement that the agency has agreed to it, not submitted to the review agency. On top of that, we have also clarified that it has to be submitted to the DEP and to the county within 30 days of granting a variance. Previously, it did say you have to submit it to the county and to the DEP, but there was no time frame. So we've clarified it has to be within 30 days of approving it. This is just one slide here showing what some of the specifics of the mitigation requirements we've added are. We did add some specifics on every single one of our standards. So if you're getting mitigation, if you're doing mitigation for a variance of water quality or quantity or groundwater recharge, we have a similar section like this for every one of those. For the sake of time, I'm not going to go over every single one of those, just this green infrastructure one. But basically, this is going to require someone to do mitigation. So let's say they don't meet green infrastructure on site. They're going to be doing it as a mitigation project. Well, they have to provide equivalent or greater treatment than they would on the major development. I think it's logical. When you try to write it out, sometimes it can be confusing, but basically if they had an acre development and they were supposed to do green infrastructure for that and they didn't, then they're going to have to go off site and they're going to have an equivalent or greater area. So it'll have to be at least an acre or more, and also has to have at least as much impervious surface. So if that acre development was 3/4 of an acre of impervious surface, their mitigation will have to manage at least an acre of total land, and at least 3/4 of an acre of that will have to be impervious surface. On top of that, you can't just use a vegetative filter strip or a grass swale alone as your mitigation. Reason for that is they would have never been enough on their own to meet the requirements on the site originally, so they can't be enough for your mitigation. Now, they could be combined with something else to do your mitigation, that's fine, but they just can't be the sole measure of your mitigation. Your green infrastructure has to be used to manage the water quality design storm. That's obvious, I think. And it has to be subject to the same drainage area limitation. So you can't, it's still, even though the rule here in this specific part doesn't point back to the standards there for the drainage area limits, this makes it clear that you do have to obey those still. And that's pretty much it for my presentation. I know I talked fast, went through that as fast as I could. We'll be here for questions. I think we're doing all the questions at the end, so we'll do them all at the end. But if you think of one later or anything, you know, feel free to send me an email. You can call my office, of course, but like most of you probably working from home, that's going to get to me eventually, but it'd be a lot faster to just email because that will go to me directly.
Okay. Thank you, Gabe. That was a great presentation. And yes, if people do have questions, please put them in the chat and we will ask them at the end of the presentations. So thank you very much. So we're going to move on to our second speaker, Mike Pisauro. Mike is at the Watershed Institute. Prior to joining the Watershed Institute, Mike was a practicing attorney for 19 years and is licensed in both New Jersey and Pennsylvania. For 10 plus years, he ran his own law firm concentrating on environmental work for citizen and environmental organizations before local land use boards, the DEP, and in litigation. His practice also included business and real estate law. He was the lobbyist for the New Jersey Environmental Lobby for 9 years, and he presently serves on the Hopewell Valley Green Team and was appointed a board member of the New Jersey Licensed Site Remediation Board. Mike received his Bachelor's of Science degree in economics from James Madison University and a Juris Doctorate degree from the University of Richmond. Mike, thank you for joining us today.
Thank you, Tom. And thank you, Gabe. Every time I hear you speak, I learn something new on this topic, so I appreciate that. So hopefully my slides are showing. So thank you. I don't have a slide on this, but the Watershed Institute is located in central New Jersey. We have been around for 70 plus years, and we've been working to keep our water healthy, clean, and safe. As Gabe has talked about the green infrastructure rule, and this has been a huge move forward on the way we address stormwater management, but it has not been enough, and DEP has been working on additional stakeholdering and additional rules coming forward. But part of that, as we all know, and we all have sort of experienced, flooding is a problem. Flooding is continuing, and it's probably in some of our areas getting worse for multiple factors. Part of that is because of impervious surface, and we've sort of changed the water cycle. So as our communities get more and more dense with impervious cover, there's less space for that water to go and to infiltrate. Also, our weather patterns have changed. So the first 7 decades, and this slide's a couple of years old, but the first 7 decades of the 20th century, New Jersey has had about 44 inches of rain. The 21st century, and I think this slide was done in 2016, so we had just over 47.5 inches of rain, which means another almost 3.5 inches of rain hitting New Jersey, which means quite a bit more water that New Jersey's stormwater management systems have to address at the same time as we are increasing our impervious cover. Recent land cover reports are showing that New Jersey has continued to convert our open spaces, our farmland, into urban space. That has slowed down, but overall in New Jersey, we're about 33% impervious cover. And again, depending where you are in the state, in your community might be much higher. So that water has to go somewhere. Also, the rain patterns have changed. We're having more frequent heavy storms, and that rain's coming down in a shorter period of time. So That has led to a bunch of things, and one of the reasons why we've, with other groups, have developed an enhanced model ordinance. So we have more impervious cover, we have flooding, we also have water quality issues, and this is from a DEP report. Basically, for the waters we monitor are not meeting designated uses, those uses set out by the Clean Water Act in New Jersey. But those aren't meeting, and for a large part, it's because of the way we manage our land. And so our current stormwater problems, our stormwater management regulations, while they haven't been improved through the Green Infrastructure Rule, are really addressed at slowing the rate of pollution, slowing the rate of which stormwater runs off our site. It's not stopping the pollution. And I hear this a lot at planning boards and zoning boards. When we talk about stormwater management, there's a confusion when DEP talks about water quantity reductions. Those are by and large, and I think 99.9% of all projects I've ever seen, are really talking about a reduction in the rate. You're actually having an increased volume of stormwater running off your site as you develop it. As Gabe talked about, with the 1 acre of soil disturbance or a 1/4 acre of regulated surface, those are the ones that get stormwater management. Smaller projects do not. In a lot of our older communities, you are seeing infill development. You're not necessarily seeing large projects. And how do they contribute to stormwater management and the stormwater issues? And the sins of the past. So before we had stormwater management rules, we had, impervious cover, and as we get more densely populated and more densely developed, those sins of the past, which may or may not have been sins back then, have come back to haunt us, and we're not really addressing that at all. So we came up with enhancements, as I mentioned. DEP's model ordinance, which Gabe mentioned quickly, has a little bit of language in there indicating that municipalities can choose stronger or additional measures in order to address local water quality and flooding conditions, as well as other environmental and community needs. So that is very important, and sort of forms the basis of why and how this should be done. As Gabe mentioned, there is the RSIS. I take a slightly different opinion of it. I don't believe that they necessarily preempt residential development requirements. I know that goes against sort of the common wisdom, but RSIS was to reduce and sort of even the bar for design standards. Stormwater management is a Clean Water Act issue, not necessarily a design or construction. And RSIS talked about where there are non-commensurate gains in the protection of public health and safety. While stormwater management, flood reduction, and meeting the water quality standards is a public health and safety issue. Also, there is a provision in RSIS talking about the requirements that do not necessarily meet the major development. So I understand there is sort of, I'm going against common wisdom, but I would posit that municipalities can go stronger both on non-residential as well as residential. So we've come up, as I mentioned, this enhanced model ordinance and has certain components: redefine major development, address smaller developments, address redevelopment, capture and treat stormwater on sites on on-site retention standard, enhance the analysis of the environmental impacts from development, have a permitting and reporting requirements, so maintenance, and then put the stormwater management requirements not only in your design standards in your land use code, but also in your zoning code as sort of a belts and suspenders method to address RSIS. So major development, right now it's that 1 acre of soil disturbance. We have recommended that that be reduced to a 1/2 acre of soil disturbance, and the 1 acre of impervious cover or regulated surface, we have recommended down to 5,000 square feet of impervious cover. The reason for those reductions is to capture more sites that may not necessarily meet the normal major development, but you're capturing more sites and getting better stormwater management. These recommendations actually came from a couple spots. One of them is from a report EPA Region 2 did on DEP stormwater management program back in 2014, and as well as the federal program for federal buildings. We also believe that all surfaces should be treated for water quality, not just motor vehicle. Even though it is a roof or sidewalk and you don't drive motor vehicles, they do have in many circumstances, a host of pollutants that come with that runoff, whether it's leaf litter, whether it is bird droppings, whether it is air deposition of nutrients and metals. And for sidewalks, whether it is sand or ice melt or whatever you've put on that surface, either intentionally or unintentionally, that runs off. And while it is cleaner, it is not clean. In a state that is not meeting most of our water quality standards, not getting these surfaces seems to be missing a low-hanging fruit. And DEP's, believe it was in their adoption document, did recognize that municipalities may want to address these surfaces. So we do recommend that these surfaces are include redevelopment. So if you have sites that did not have stormwater management beforehand, they're redeveloped, they don't meet new standards. In some regards, they're somewhere in between, but from a quantity reductions, if you have a pre-development impervious surface, all you have to do is match the rate runoff of that. So impervious to impervious, you're not getting a reduction in rate. So we think having a redevelopment standard that treats all surfaces as if they were green open spaces when you redevelop makes sense and helps address those since the past. And then an on-site retention standard. So you keep on site, don't let that discharge from your property. The 95th percentile rain event, which is about 1.5, 1.7 inches. DEP, and I joined a few minutes late. I don't know if Gabe mentioned this, but DEP is looking to propose as part of their NJDEP rules, an on-site retention standard of the water quality design storm. But this 95 percentile rain event is what the federal government uses as an option for their developments. So we believe that helps mimic the on-site in a good condition and keeps that from harming downstream. So that's those major development recommendations. We have the minor development. So if you don't have major, so many of our properties, we add impervious surfaces, whether that is patios, additions, whether there's just a small building, commercial building or residential, but they are contributing to the stormwater management problems that we are having. They are contributing to the volume flowing off our sites. They're contributing to the pollution loading. So minor development that is triggered at 250 square feet. If you have that trigger, you treat 2 gallons per square foot of stormwater, you run that through a green infrastructure system. You retain on site the 95th percentile storm to the extent you can. Again, have a redevelopment standard. So if you remove impervious and replace it, you are treating that stormwater. Unlike major development, where you can get a variance, but you have to do a mitigation project. Minor development, not required by the rules. We're suggesting there may be circumstances where it might make sense to waive those requirements for the municipality to get a mitigation fee, to use that for projects within the township, hopefully within that drainage area, to provide some flexibility for these small projects that may not make sense, may not be able to do these minor development stormwater managements. A great example, a property owner wanted to put a rain garden in as part of some work they were doing on their property. The site ran downhill, and the best place to put it was in the floodplain of a stream that flooded all the time. Didn't make a whole lot of sense to do it there, so this provided some flexibility. Also, enhance the analysis that applicants are supposed to do when they submit their stormwater management plan. really dial in the on-site mapping and analysis of environmental features, including forests. Are there core forests that you're now going to impact because you've reduced that forest? Include all of the waterways, not just category 1 and upstream tributaries. Take a look what the long and short-term impacts of that development is. If you're changing the hydrology of that site, even though if you stayed away from wetlands, but you've changed the hydrology by moving water away from a site, from that wetland, what is that long-term impacts on those wetlands or streams? What's the impacts to adjacent property owners from a volume? Are you increasing the volume downstream? And hopefully the on-site retention standard deals with that, but even though you've met the quality, quantity, and recharge requirements, you have put more volume downstream, and what are those impacts? And those non-structural or low-impact design standards that Gabe talked about, moving out of the design and putting them into the planning requirements from the municipality, we think those are important to keep within the design. Green infrastructure, and especially the small drainage area requirements, may do a lot of that, but those are very important. Using nature, using existing site conditions to manage your stormwater before you start designing systems seems to be better in line with green infrastructure than not. So keeping those in sight, I always use as an extreme example, and I admit it's extreme, but you could raise the entire site, regrade the entire site, remove all the vegetation, put a rain garden in. You've met the green infrastructure requirements. You have not met the non-structural strategies, and you sort of missed the whole point, we believe, of the green infrastructure rules. So keep those in your design. It's something we're all used to, whether it's been complied with or not. It's hard, engineers will tell you it's hard to comply with, but it's something that's been there, something we can improve on how you comply with it, not to throw it out. And again, this is something DEP is looking at bringing back sometime in the future, possibly. Keep it in at this point. And then require inspection. So again, one of the things we've all seen is you put these systems in, are they being maintained? If they're not being maintained, are they going to function appropriately? So part of the MS4 permit that all municipalities have is a requirement for all these systems to be maintained and for the municipality to report on that at the end of the compliance period. So this is a tool to allow municipalities to actually have the information so they do that certification, they're being accurate. Have all the property owners that have a BMP apply for a permit, they submit reports that these things are they're being inspected and being maintained, and those maintenance records are submitted. Auditing by the municipalities to make sure those reports are accurate. Whether there's a fee or not, that's really up to the municipality, but it makes sense to have a small fee to cover the cost of the inspection program. And again, this just we look at it as a way to assist the municipality comply with their requirements. And so that was, again, a whole lot of information in a very short period of time. We have a handful of webinars on our website dealing with the green infrastructure. We have a copy of our model ordinance on our website, and I have in here that RSIS issue. We're doing a webinar on December 2nd to really talk about why RSIS is not the impediment that common perception it is. We also have some training on green infrastructure. And as Gabe said, we are here to answer questions, to provide information, to guide municipalities and others as they go through the stormwater management. So thank you very much for this opportunity. And as Gabe mentioned, we'll take questions at the end. So thank you.
Thank you very much, Mike. That was a great presentation. Okay, like I said, if you can, put your questions in the chat and we'll try and ask as many as we can at the end. So please get them in there. Next speaker is Chris Obropta. Chris is the director of the New Jersey Water Research Institute and extension specialist in water resources with Rutgers Cooperative Extension. He's also professor in the Department of Environmental Sciences at the School of Environmental and Biological Sciences at Rutgers. Chris leads a highly specialized staff from the Rutgers Cooperative Extension Water Resource Program to identify and address water resource issues by engaging and empowering communities to employ practical science-based solutions to help create a more equitable and sustainable New Jersey. Over the last several years, he and his staff have been working with communities to implement green infrastructure practices throughout New Jersey. Chris, always an entertaining speaker, so I'll give the floor to you.
Thanks, Tom. Can you hear me? Is that okay?
Yeah.
Good?
Yep. Everything's good.
Great. Okay. Yeah. So this is me, and that's my my mission statement. I work for the Cooperative Extension Service here at Rutgers. Most people know Cooperative Extension as the folks that help the farmers out. We have an office in every county. There's an agriculture agent in each of those offices. We do a lot with 4-H as part of Cooperative Extension, but really our job, Cooperative Extension, is really extend the knowledge university out to the state and help people solve their problems. So I have a full-time staff of 10 people, engineers, scientists, landscape architects, and we make our way through all of New Jersey trying to work with different communities to implement green infrastructure practices and deal with stormwater problems and all kinds of different water resources issues. So this is our mission statement with all the buzzwords in it as possible. We had to add equitable the other day for some reason. I'm not sure why. I guess that's the new buzzword, but this is us. So I've got a real quick presentation. I just kind of want to touch on a lot of what Gabe had said and talk about it from a practical standpoint of what a town should expect to see when developments are coming in for approval. I sit on my environmental commission in my town, so I see a lot of development plans come in. And this is DEP's definition of green infrastructure. Okay, and it's a good definition. Talks a lot about infiltration, filtration, storage. Green infrastructure is really, the point of it was to try to restore that natural water cycle, that we've completely disrupted by adding all the impervious surfaces in our state. So, and the idea with green infrastructure also is to manage stormwater at its source. So the days of having a 50-acre subdivision with 50 homes on it and a big detention base at the bottom of the hill are probably over. You're going to see a lot more smaller systems scattered throughout the development. And most of the drainage areas will be less than 2.5 acres for these green infrastructure practices. So Gabe showed you these tables, and it's a lot of, I think if you stare at this long enough, the headache might go away, but it's kind of hard to follow some of this stuff. But I guess the important point here is there are 3 major things that you still have to satisfy with the regulations, and that's the TSS removal, the removal of sediment. So you still have to remove 80% of the sediment. You still have to address the water quantity, so reducing the peak for the 2-year, the 10-year, and the 100-year storms. And then you have to maintain your annual groundwater recharge. So if the development was recharging 1 million gallons of stormwater a year, after you put up your houses or your factory or whatever it is, it has to be recharging 1 million gallons of stormwater a year. So those are the 3 main things, and that's been there since 2004. It was great that they went from just doing quantity. You also look at recharge and sediment removal. So now we get quality and groundwater recharge. It was a great move by the state of New Jersey, really kind of ahead of a lot of the other states. So these are the different practices. You'll see here that none of these really satisfy all those requirements, right? So, the first column needs to be at least 80% or more, and there's only one, the manufactured treatment device and the vegetative filter strip. Maybe you can get up to 80% with that. But the runoff quantity, there's only a few of these that you can do that with, a cistern and a green roof. And then the groundwater recharge, really only the dry well is the only one that can achieve that. So you're not going to see a lot of these practices for major development, and Mike talked a lot about adding a minor development component to it, but that's a little bit different. But then we start looking at these other practices here, and we start seeing that, wow, these actually can satisfy this. So all 4 of these can satisfy all 3 of the requirements, so that you can get the stormwater quality requirement, the TSS removal rate, 80% or more. You can reduce the peak flow from the 2, the 10, 100-year storm using all these systems, and you can promote groundwater recharge for all these systems. Now, some of these say yes and no. The no's mean that you cannot get groundwater recharge because there's clay or there's other surfaces that water can't get into. In most cases, if that if those restrictions are there pre-development, they're going to be there post-development. So groundwater recharge requirement may not be important, because if you're not recharging anything now before you develop, you shouldn't have to recharge anything after you develop. So that's kind of the point with that. So let's talk about each one of these systems. So you're going to see a lot more pervious paving systems, I think, in New Jersey, a lot more porous asphalt. We're seeing a lot of this already. A lot of developers that come in my town have realized that they can use porous asphalt as a great stormwater practice. The idea is the water passes right through the asphalt, doesn't have the fine material in it, and goes into a stone layer underneath. And that stone layer cleans the water, so you can get an 80% TSS removal, total suspended solids removal. It also can do groundwater recharge, and then you can make that stone layer under the parking lot big enough to hold the water and to reduce the peak flow from the 2-year, the 10-year, and the 100-year storm. So the 2, 10, and 100-year storm are design storms that we engineers use. So a 2-year storm is about 3.3 inches of rain over 24 hours. The 10-year storm is about 5.2 inches of rain over 24 hours. And the 100-year storm is anywhere between like 7.8 and 8.8 inches of rain over 24 hours, depending on what county you're in. So that's, it's a lot of rain. So these systems can be designed to handle that and to manage that and to reduce that peak flow. And they're very, very good systems. Okay. There's different types of permeable pavements. There's porous asphalt, pervious concrete. Both are very similar to the original material. So the porous asphalt is just regular asphalt without the fine material. The pervious concrete is also regular concrete without the fine material. Okay, and water can pass through it. There's also these grass pavers, and then there's the permeable paving system, so the paving stones, right? So here's kind of how it works. There's a cross section of it, and you can see the stone underneath the parking lot has a void space of about 40%. So for every 2.5 gallons of stone, you can hold about 1 gallon of water. Okay, so that kind of gives you an idea. So for every foot of water you need to store, you need about 2.5 feet of stone. Okay, so that tells you how deep you make it. And most of the porous asphalt parking lots only have 6 to 12 inches of stone underneath it. Usually they don't have that much. Okay, so that's important. So I don't know why Ness Cohen's writing on my slide. Stop writing on my slide, Ness. Okay, so anyway, so so the other thing that happens with this is because it's porous, it breathes, right? So what winds up happening is air can pass through this this system, so it doesn't heat up as much. So it reduces the heat island effect too in the cities, because in the cities we have asphalt, any black surfaces, retains heat, and holds it overnight. So it takes more energy to cool down the city, and it can create a big heat island effect. Okay. There's a parking lot that we had done in Clark. You can see only the parking spaces are done with porous asphalt. The cartways where you drive in is regular asphalt. The porous asphalt tends to be a little bit weaker than regular asphalt. So when you turn on it, you can ridge it out. So we really only use it for the parking space. We don't have to use it for the main road. Plus, we can have that entire cartway there drain onto the parking spaces, and we can manage it under those. So it also saves us some money by just doing the entire parking lot. Pervious concrete. There's one issue with this is that if you oversalt it, it can break it up. So we try to be very careful about that. You really need to get somebody who's a specialist in pouring this. There's guys certified who can put this down. But now they also have a place in Pennsylvania that makes this precast, so pre-manufactured. So they pour it in a warehouse, they cure it in a warehouse, and then they deliver it on site as slabs. So basically, you're getting a 5-foot by 5-foot concrete slab delivered to the site. You take it off the truck and you drop it on your stone bed, and now you have your pervious concrete sidewalk. So it's a pretty nice way of doing things. Okay. Permeable pavers. Well, this is for the ultra rich, I imagine. Very expensive. Infiltration through this is a little bit harder because it only infiltrates the slots between the paving stones, right? And those cracks between the stones where the water infiltrates through can get clogged, particularly if you have landscape surfaces nearby that aren't stabilized and you have soil washing onto that. So you'd have to do some work to clean these out on a regular basis. So that's another important factor. And then we have grass pavers. These are great. I mean, this is behind a public works building in Parsippany. What happened here was this was a fire access road. The water would fill up on this road, and the road would seep into the building and flood out the head of the public works office. So we replaced this road with this turf stone. It's really just a concrete block that's 1 foot by 2 foot with those diamonds in it. We fill the diamonds up with soil, plant some grass on it, and underneath this is about 6 inches of stone. So water lands on this, goes right through the system into the stone. They had about 6 inches of rain after we had put this down, and not a drop of water made it into the head of Public Works office. So it worked out really well. It's a great system. Okay. Small scale bioretention. So we keep using the term small scale because we have a small drainage area for this. So like Gabe was saying, a 2.5 acre is a maximum drainage area you can have for a lot of these systems. So bioretention systems is a neat word for rain gardens. So we tend to call it that a little bit easier because people understand that more. And they're just shallow landscape depressions designed to capture stormwater and infiltrate it into the ground. Usually it'll fill up with 6 to 12 inches of water. Within 48 hours, that's usually into the ground. It has to be drained within 72 hours or mosquitoes start to breed. So we engineer a soil mix that goes in the bottom there so it drains pretty quickly. You can put these anywhere. That's what's great about them. They can get incorporated to any landscape. You can see the picture on the left-hand side. You have one in a parking lot island. The picture on the right, lower right, is one off the roadway, taking roadway runoff. The picture in the upper right-hand corner is in the courtyard of a school where the kids were planting it. You have one at the library, and the center picture on the left. And the picture in the very center is an abandoned gas station in Camden. We actually built into a rain garden park. So there's 4 rain gardens in there, and now it's the gateway to the southern ward of Camden. So here's one at a school. We use the existing inlet, dug around it, 6 inches around it, 6 inches deep. So that'll fill with 6 inches of water. The water will sit there until it slowly percolates into the ground. When you get 7 inches of water, it'll overflow and go into that inlet and go on its way. Here's the one in Camden. This is really nice because you can see they have a trench drain in the upper left-hand corner, taking the water from the road under the sidewalk or through the sidewalk into the rain garden. So you can get road runoff even though the sidewalk is in the way. And here's one for another parking lot. You can see these stone entrances, curb cuts, water getting in here. Beautiful system. Lots of pollinator plants. Really, really nice. And this is a stormwater management system. You don't have to mow it every week. I mean, you do have to weed it occasionally and maybe trim it back a little bit, but it really can add to the aesthetics of a building. Okay. So there's 2 other systems that are going to be very popular as we move with these stormwater regulations forward. One is this infiltration system. So now we're talking about using a sand bottom to get water into the ground. The problem with these type of sand systems, they tend to clog a little bit on the surface. This is a technology that was adapted from the wastewater industry. And in the wastewater industry, we do have piping underneath this, and we can backwash it and pump water up through it to kind of flush it out. Very similar to the way you would backwash a pool filter for your pool. Okay, so you can get stuff kind of settling on top of this and a crud or a film buildup on this. And you have to go actually in and manually rake it out and break it up so the sand will continue to work. But the idea is the water is captured in here and it infiltrates into the ground. The biggest problem we see with these systems is you'll notice that there's a seasonal high water table there, and the water table underneath the ground changes throughout different seasons. So this time of year, it's increasing. It's getting wetter, so the water table's coming up a little bit. So the biggest issue we have is when people build these things or design these things, they don't do a very good job of estimating seasonal high water table, or they make a mistake on that. And then they wind up digging these systems down into the water table. So in the summer when they build it, it's great, it's bone dry. And then in the fall when it starts to rain, the water table comes up and the bottom of this stays wet and it doesn't infiltrate. So that's one of the big problems we can see with these types of systems. So you really need 2 feet minimum separation between the bottom of the system and the seasonal high water table. That's an important factor here. Okay. These also have been incorporated into extended detention basins. So you have the detention basin that can actually manage, the 10 to 100-year storm, but now you have this infiltration trench in the middle, which is basically a sand trench and allows water to go into the ground. So it's another kind of way to use this infiltration system. Okay. And then here's a cross section of it. So you can see this can handle all the different storms, the 10 to 100-year storm. And then when you have the water quality storm, that just sits below the outlet and infiltrates into the underlying soil. Okay. The other one is a sand filter. So this sand filter, in this case, is showing you actually have topsoil on top of the sand with some grass, which is a little better because now that helps break up some of the stuff that's going to come in, and you're not going to get that film on top. You still may have to go and aerate that grass occasionally and rake it out, but it's probably a little bit less maintenance, this type of system. Once again, you got seasonal high water table issues. You got to make sure that you're 2 feet above that. But this is another system you're going to see. So the infiltration system is sand filter. And here it is with a pre-treatment zone in front of it. So you actually have a place where water comes rushing in with all the sediment settles out in that area, and then it kind of overflows and goes into the sand bed where it infiltrates into the ground. Now, this one has an underdrain in it. So you can put an underdrain system in this, so you can still get you could still get some of your water quality achievements with this. So water will pass through the sand, it'll get clean, you'll get your 80% removal, but you won't get your infiltration with this because now it's being taken away with the underdrain. Okay, so that one table says yes and no, and that's because if you have an underdrain, you can't get groundwater recharge with this. Okay, but sometimes you don't need that because it's all clay anyway, it's not going to recharge, so the underdrain is okay. And it's another cross section of the underdrain. So this is my last slide. So as these new regulations come out, these are the 4 systems I think you're going to see most of. Now Mike was talking about having a minor development component, so you're going to see probably cisterns and other things associated with that minor development component. But from the major development side of things, you're going to see a lot more pervious pavement systems, a lot more bioretention systems or rain gardens, a lot more infiltration basins and sand filters. And that's going to be used to achieve all these requirements. I think it's a great process, these green infrastructure practices. I like the fact that they're small. The other real issue that towns are going to have, though, is that instead of having one system for development, you may have 10 or 12 of these smaller systems. And now you still have to, under your MS4 permit, make sure that they're all being maintained properly. Okay, so you're going to have to do a lot of follow-up with that. There's going to be a lot of documentation that has to happen and databases built to kind of track where these systems are so the towns can make sure that they're being operated properly. So this is my contact information. Feel free to send me an email or you go to my website, you get my number, and you give me a call if you want. I'll be glad to talk to you more about this. Thanks.
Thank
Good,
you,
Tom?
Chris.
Okay,
Yep,
thanks.
that was good. Thank you very much. I feel like I'm a student in your class all the time. So thank you very much. Okay, our final presentation this afternoon is by Jim Cosgrove. Jim is the Vice President and Principal of Kleinfelder, an international environmental consulting firm providing solutions to water, transportation, and energy markets. He's a registered professional engineer in New Jersey with 30 years of experience in water resource management with specific expertise in water quality modeling, watershed and stormwater management, and environmental impact assessment. So Jim, welcome, and we look forward to your presentation.
Thank you. Can you see my screen?
Not yet.
That's interesting.
Oh, it looks like it's coming up. Yep, we can see it.
Okay, great.
All right.
Well, thanks for having me today. We've talked a lot about a lot of different things, some of which was associated with new development. And then as Chris just mentioned, whether the stormwater BMPs you've heard about today are built as a result of new development, or they're things that you might be interested in at the municipal level for a retrofit, these things cost money. So how do we pay for them? And so, well, that's interesting. Bear with me for a second. Okay. How do we pay for these things? So right now, the way we're paying for them at the municipal level would be with municipal taxes, maybe through some NJDEP funding. Perhaps you can get a 319H grant, or you can get funding through the New Jersey Water Bank. And there are also charitable foundation grants. All those things can be used to pay for stormwater improvements and maintenance. We've got something new now that we can use called a stormwater utility. And a stormwater utility is a way to fund the costs of these things. So in March of 2019, the big change was that the Clean Stormwater and Flood Reduction Act was passed by Governor Murphy. This was the first time where a stormwater utility was actually authorized within the state of New Jersey. So the act authorized municipalities, counties, certain authorities to establish stormwater utilities. And it recognized that problems affecting residents due to inadequate stormwater infrastructure management resulted in health and safety issues, economic well-being, and quality of life issues. So it also recognized that stormwater infrastructure in New Jersey really lacked a dedicated source of funding. I've been involved in a lot of situations where in a particular municipality, there was enough money to repave roads or deal with some pipes underground. And usually the money goes towards things people can see. So the roads get paved and the crumbling infrastructure beneath the surface doesn't get updated. So this is a way to provide for that dedicated source of funding. It allows for a fee-based assessment, and this is an important part of it, based on a fair and equitable approximation of the proportionate contribution of stormwater runoff from real property. What that really means is the more stormwater you produce, the more you're supposed to pay as a fee for stormwater management. Now, this is new in New Jersey, but it is certainly not new in the US. There are over 1,700 stormwater utilities across the country. And one thing you might find interesting is the annual user fee runs at about $50 an hour, $50 a year, excuse me. And so the cost is not great, but the money that goes into that pot has to be used for stormwater management. So what are the benefits of a stormwater utility? Well, as I mentioned before, it provides that steady, dedicated revenue stream. The funds are directed solely for stormwater management. The need for capital improvements and revenue requirements increase as infrastructure ages, and we often don't have the money to deal with that. So you have a predictable, steady stream of money. One of the things you often hear about the stormwater utilities is, oh, it's just another tax. Well, it's actually a more equitable way to pay for stormwater than a tax, because it apportions the fee based on the amount that's being contributed. One of the things that I always find interesting is that where stormwater utilities have been used, we often see cost savings. So there was a survey of 40 municipalities not too long ago, and the average residential property owner saved 50 to 70% by paying a fee rather than paying the amount through their property taxes. The other thing you got to remember is fees can be collected from tax-exempt users. So the example I always use is I live in Princeton. Princeton University owns a very large percentage of the property in the municipality of Princeton, yet they don't pay property taxes. So this is a way for everyone contributing stormwater to a municipal system to pay a fee to manage that stormwater. The other thing that's different with the stormwater fee is that it provides for credits based on the level of service received. So for example, if a homeowner put in a rain garden like Chris was just describing, they would be able to get a credit off their stormwater fee. So it provides incentives for property owners to reduce impervious surfaces or to manage their stormwater in a more efficient way. So really, on the left side of this slide, you're seeing how we're paying for stormwater today. A homeowner in a residential, single family home pays for stormwater through their property taxes. However, on the right side, you see a school with a tremendous amount of impervious surface. No revenue is collected from that school to manage stormwater. So how does the stormwater utility work? First, you have to form the utility. And one thing that most people don't think about is the fact that you don't need to form a new group to form a stormwater utility. In fact, I advise against it if you can. A stormwater utility could be formed through an existing utility. So there might be a regional municipal utility authority, or there might be a county authority, or even a municipal public works department could form a utility. Once the utility is formed, fees are assessed. And as I mentioned, there's credits provided for impact reduction, and there's credits provided for green BMPs. So we promote the green BMPs that Chris was just talking about. And then finally, we collect the fees, and the funds that are collected end up being reinvested. And they could be reinvested by through studies, design, and engineering, and any consulting costs that are necessary to design improvements, and then also towards the actual maintaining, repairing, and constructing the stormwater infrastructure. So one of the things I just want to leave you with is the fact that water doesn't follow municipal boundaries. So I would highly suggest, if anybody's interested in forming a stormwater utility, think regionally. Collaboration provides for a regional solution. There are a lot of advantages to doing a stormwater utility on a regional level. First of all, it supports watershed planning. Watersheds are typically not found, part of the watershed. The municipal boundary does not form the watershed boundary. So we get better solutions when we do watershed-based planning. It's a much more cost-effective way to doing it. If each municipality in a watershed does a stormwater utility, it's not going to be as cost-effective as if they get it together and do it at a larger watershed basis. You eliminate duplication of efforts. You get economies of scale. You also maximize your opportunities for grants and loans, and it often streamlines regulatory requirements. Keep that in mind. The regional approach usually, almost always, will result in a better way, more efficient way of dealing with stormwater. So how do you do that? One of the things that I've always found is you need leadership. You need a champion who's really going to take this on. And that champion needs to be willing to spend some money often up front to get things started. Now, just a note on that, New Jersey is really encouraging people to do stormwater utilities. And so right now, if you were interested in forming a stormwater utility, you could likely get some money from New Jersey DEP to help with the upfront cost to do that. So keep that in mind. And ultimately, in order to implement the regional approach, you have to develop a plan that demonstrates real improvements at a reduced cost. That's really the key to the regional approach. So I wanted to just leave you with some stormwater utility resources. DEP New Jersey Future, Rutgers, and EPA all have really good information on stormwater utilities. So I encourage you to look at these sites. There are other links on these sites to other places that really have great resources for you. So if you're interested in doing something like this, take a look at these sites. It'll give you a lot of ideas. Feel free to reach out to me if you have any specific questions. So I'll stop there so that we allow plenty of time for questions and discussions, and turn it back to you, Tom.
Thank you, Jim. Very enlightening presentation. So we did get a few questions come through the chat, so I'd invite all the panelists to turn their cameras back on and microphones. You may all want to weigh in on these answers. The first one came in during Gabe's presentation, and the question was, if it takes 72 hours to drain one of these green infrastructure systems in the 100-year flood event, explain what goes to the green infrastructure and what does not. Would there be a separation of water going into those structures versus bypassing those structures in the most extreme cases?
Well, generally there wouldn't be. I mean, it really does depend on how the site's designed, I suppose. But if you're using it to manage the 100-year storm, then you're not really going to have much bypassing it, because you're going to need to have most of your development draining to whatever system you're using to manage the 100-year storm in order to meet the requirements in the rule. And the 72 hours, that's just the absolute maximum time frame. So keep that in mind. Of course, your basin could potentially be drained 12 hours or 36 hours. Depends on its exact time, but you can't exceed 72 hours. After that point, we consider your basin not to be functioning properly.
Okay, thanks. Anybody else want to add to that, or? Okay, all right. The second question from David Silver. I live across.
This is Jim Bay on the first question. Are we allowed or inappropriate to speak at this point?
Oh, go ahead.
Yeah, no, go ahead, please.
Please. Take a random development that has a 3-acre retention basin 3 feet deep, and it's got a 72-hour drain through like a 3-inch in the bottom, and then it has the overflow grid up at the top the way any normal retention basin would be. What portion of the water going through a 20-year event, which would then get this 3 or 4 feet deep in a normal retention basin? I don't understand the concept. What portion of that very routine water that goes into a very routine retention basin must permeate, etc.? And I understand that that very routine retention basin, 3 or 4 acres, 3 feet deep, would need to drain within 72 hours or it becomes a mosquito phenomenon. Within that 72 hours normal draining, what are you requesting not leave the site?
Well, okay, it's an infiltration basin, which I think is what you're saying.
Well, primarily an old-time retention basin that we would have had 10, 15 years ago.
Yeah, that's why we're not building them anymore.
You're not going to have that anymore.
That's why we're not building them anymore, because they don't work like that. that's the issue. No, I mean the whole point with this was that those basins do very little for water quality. They don't really manage a smaller storm. They pass it right through. They got those concrete low flow channels, and water gets in and shoots right through there. So those old basins really don't function the way we're trying to get the new systems to function. So the idea is that the new basins will have that 3-inch pipe that you talk at the bottom of the basin is going to be 6 inches off the bottom. So you're going to get 6 inches of water that goes in the basin. It's going to sit in there, and that's going to infiltrate into the ground. And anything after that's going to go through that 3-inch pipe, and there's going to be a bigger hole in that box above it, and even a bigger hole above that. And all those holes and sizes of those openings into that concrete box are engineered so that the peak flow that comes into the basin is released much, much later and a much, much lower peak after the storm, right? So the idea is we have to reduce the peak for the 2-year, the 10-year, and 100-year storm to be less than the pre-development peaks, right? So the water's going to come in and go out of those systems very slowly But the idea is that first runoff, that first flush that we call it, which has all the pollution in it, is going to get infiltrated into the ground, and it's going to stay in that basin until it can slowly percolate into the ground. And then anything coming on top of that is going to be released slowly over time. So those old time basins just don't work like that in most cases, you know.
Okay, Chris, this is Jim Bay again.
Yep.
If we were to take just a standard historical one and just for classroom purposes, retrofit it with the 3-inch discharge being 6 inches above the bottom, just
Yeah.
so I can get a mental picture.
Mhm.
So before it goes into the 3-inch discharge, it's now appropriately 6 inches above, and then there's 6 inches of water sort of sits in there for a period of time, while within 72 hours, the remainder above the 6 inches drains. Is that accurate?
Well,
or
no,
not?
that 6 inches has to drain within 72 hours too. So the entire thing would have to drain. So that 6 inches would go into the soil over 72 hours, and the rest would be going out the discharge. The problem is your basin that you have in your development is not going to do that, because when they built that basin, they built it with rubber tire vehicles and they compacted the hell out of it, and there's no infiltration going in that basin. So you'd have to really go in there and retrofit that basin. And we're doing some of that now, and they've done a lot of this in Ocean County, where they dug up the basin, loosened up the soil, so kind of uncompacted, so the water will infiltrate into the ground, right? So that was the problem with those detention basins that are being mowed every week, is that, you know, they don't do a lot for infiltration because the ground is so compacted,
Okay,
and they
Chris.
weren't designed to infiltrate. So that's a bigger part of the issue. But you're right. I mean, the idea would be that any water that goes in the basin within 72 hours has to be gone, according to New Jersey DEP standard, unless it's a wet pond. That's a whole different system. But you know, if it's a detention basin like you're talking about, it has to drain within 72 hours. So, is that better? Did I get that right or no?
Chris, I think getting into very much design details on a retrofit.
Yeah, I'm sorry about that. Yeah.
So I think we have a few more questions that we'd like to get to. So let's try and move on. A second question was, in the case of a stream-fed lake that fills with sediment that requires dredging, and in this one case, the questioner says it was dredged several years ago, but is still receiving sediment and requires more dredging. Is it the responsibility of the municipality or the state to dredge these lakes and remediate them?
I think DEP should do it, right? Right, Gabe? Is that
Yeah.
right?
Well, I think when you say responsibility, that's a tricky question, because it's probably no one's responsibility to do that. No one is mandated under law to ever do, unless this is like a channel where there's boats going that need to maintain that flow of traffic, which I don't think is what you're describing. So I don't think anyone's obligated to do that. Anyone can do that, but of course you need to get property owner permission to be able to work on their property. And if it's a lake, you're going to need to get permits from the Department of Environmental Protection to be able to do that work.
And it has been our experience in Monmouth County working with the coastal lakes that it's a challenge to get the lakes dredged, just due to the sediment qualities alone. Here's a next question is, will the adoption of the enhanced ordinance be mandatory on municipalities?
No. DEP's, the Green Infrastructure Rule that DEP published in March, that's mandatory. The proposed enhancements we would like to see done at the same time, but they're not required. I'd like them to be required, but they're not.
Okay, and that's all the questions we had in the chat, unless somebody wants to type one in real quick. In the meantime, I'd like to thank all of our panelists for great presentations and really great information for the communities and the people that attended. I think I know I have a much clearer understanding of what the new ordinances are, and the stormwater utility in particular, that I think some communities are starting to move forward on. Okay, so we're at 1:30. I want to be respectful of everybody's time. So again, thank you very much. And we will have a recording posted of the session on the Urban Coast Institute webpage, maybe as early as tomorrow. We'll see how hard Carl can work. So, all right. Thank you very much, everyone. Have a
Thank
great
you,
day.
Andy.
Thank you.
Thank
Thanks,
you.
Tom.
Thank you.